here I am going to show you one of the most common modeling application that you can see in algebra. It has to do with firing a projectile. Okay, and what that means is that we are going to be using a very specific formula in order to calculate that. So we are looking at a modeling application, and so specifically we are looking at this physics formula, which says we have h, which is your height, equals -16. Now this -16 is your gravity, and in this case we're using gravity in feet instead of meters, and so that's where the 16 is coming from. It's because we're coming from our gravity term, which is 32 feet per second squared. And the formula itself really starts with a 1/2 out here, so it's 1/2 gravity t squared. That's where 16 comes from. The t stands for your time, v0 is your initial velocity, and h0 is the initial height, in other words the starting point. Okay, so this is the formula that we are using, and what you have to do with your problem is you have to identify these different variables within your problem and then be able to apply them into your formula. Now most of these start out by requiring you to have to create or write the formula to use. So you do have to remember the very basics of that physics or motion formula. So here we've got a projectile filed vertically upwards from a height of 200 feet above the ground with an initial velocity of 1,100 feet per second, and you need to round all values to the nearest hundredth as needed, and you're going to use just that information in order to answer the rest of these questions. So the first part wants you to write a quadratic equation to model your problem. Okay, so to do that, what that says is that we're going to start with h of t, and then because we're in feet per second, we're going to have -16 t squared plus my velocity. So my velocity here was 1,100 feet per second, so this is 1,100 t. And then we have our initial height. So that initial height we have right here, which is 200 feet, so plus 200. And that is the equation that you have to use. So for the first part, that's all we're looking for. Now the next part wants you to determine the height of the projectile after 5 seconds. So essentially what we're doing is we're trying to find how far it is after 5 seconds have passed. So we are looking for h of 5, which means anywhere you have a t, you're going to plug in 5. So this is going to be -16 times 5 squared plus 1,100 times 5 plus 200. So here you're going to go ahead and solve. So for this first part, 5 squared is 25 times a -16 gives you -400 plus 5,500 plus 200. Put it all together and we get 5,300 feet. So your projectile after 5 seconds is going to have a height of 5,300 feet. Now the next part wants to know the maximum height the projectile will reach. Okay, so essentially if you think about it, this is a quadratic, and so what we're doing with this quadratic is it has, if you look here, a negative. So if we were to graph this, okay, and we would have this graph here like this, our function would look something like this, okay, where we would have a starting point and we would have an end point. And then what would happen is that the bottom axis here is your time, and your y-axis is going to be your height. Well, what that also means is that right here is your vertex. And there's a few things that we know about the vertex. Okay, the vertex is going to give you the maximum height. Okay, so here when we're looking at that, one of the things we know is that your vertex is going to be comprised of negative b over 2a, function of negative b over 2a. And what we know about that is we know that this piece right here, the y piece, is going to be your maximum height. So in order to find your maximum height, we have to figure out what your maximum time is, or the time at which that you reach in terms of increasing. That time where you're no longer increasing, now you're decreasing. So first, in order to find time, we have to have negative b over 2a, which means we have to refer all the way back up here to our initial equation. And so here, my negative b is negative 1100 over 2 times my a term, which is negative 16. Okay. So we're going to calculate that, and so in this case you're going to end up with 34.375 seconds. And since we want to round to the nearest hundredth as needed, we can go ahead and do that. And so this would essentially be 34.38 seconds. Now with that, this is only time. I have to find my maximum height. So your maximum height is found by doing the function of your time. So in this case, what we're talking about is we are talking about negative 16 times 34.375, and the reason why I'm using 375 is because this is an exact decimal, and so I'm going to go ahead and use the exact version. Okay, and we're going to square that. We're going to add it to 1100 times 34.375, and we're going to add that to 200. So we're going to go ahead and solve all this down, and what you end up with is 19,106.25 feet would be your maximum height. And so this right here is the result that you were looking for in this problem as your maximum height, and this right here would be the second piece, which is the time it takes to reach that height. Now, a couple other questions that you could be asked is, what does it mean when the projectile hits the ground? And so there's a couple ways that you could answer that. First, one of the things we have to recognize is that ground means that you have a height of 0. And so you could take a look at what does it mean when you have a height of 0. Okay. One of the ways I like to look at that is to say, okay, that would mean I would have that 0 is equal to negative 16 t squared plus 1100 t plus 200. And when I'm looking at ground or hitting the ground or having a height of 0, I could look at how long does it take to have that happen. And so here we would have that your time is equal to negative 1100 plus or minus the square root of 1100 squared minus 4 times negative 16 times 200. And this whole thing is over 2 times negative 16. And so we would go ahead and reduce that down, and we would end up finding that t is negative 0.18125 or 68.93. Now in this case we would cross out the negative, and the reason for that is because your time cannot be negative. Negative would essentially mean going back in time, and we don't do that. And so what we would find out here is that the entire trip takes 68.93 seconds from start to finish. Now the other thing that it can mean when the projectile hits the ground is you could also look at it as it means that your projectile is at rest. Okay? So there are many ways that you can go about what it means when your projectile hits the ground. Okay, so whether you're looking at the trip and the entire trip it would take, or you're looking at what it actually means is happening, it just depends on your view on the question and the context that you're trying to answer. Now the last thing we have is when the projectile would be more than 8,000 feet above the ground. And so because we have the word more than, what this tells you right here is that you are looking for an interval. Meaning, because we know that this is a quadratic equation, which means it is a parabola, there will be a period of time where your projectile would be at a height that's greater than 8,000 feet. And we want to find the actual interval over which that happens. So this is telling you that you have that 8,000 feet is your height, and you have minus 16t squared plus 1100t plus 200. And so we need to go ahead and solve. So to do that says we set it equal to 0. And now we can identify our A, B, and C, because what you really want to do is use the quadratic formula. So we would have that your t is going to be negative 1100 plus or minus. We've got a fairly big radical, so we've got 1100 squared minus 4 times negative 16 times negative 7,800, and the whole thing is over 2 times negative 16. So when you solve that, what you're going to end up with is you're going to end up with two results, 8.03 or 60.72, and this is in seconds. And so what this means is that the projectile will be above 8,000 feet from 8.03 seconds to 60.72 seconds. Okay? And so that's how long that projectile is going to be above that 8,000 feet before it comes back down. Okay, so there you have it, a projectiles question where you have quite a few different versions of the questions that could be asked. So if you have any questions, let me know. Otherwise, I hope you had as much fun as I did, and I'll see you next time.